This conference will now be recorded.
Thank you for joining us today. We're going to be talking about Cadwelds from Invent Erico, about the benefits of using a Cadweld, and also how to assure that you get a proper Cadweld, that it is going to fit your network and it's going to provide you with a proper ground network for safety and use of equipment. So first off, with Cadwelds, Cadweld was first introduced. It's an exothermic connection. It was the first one to the market way back in 1938. This is the original Cadweld that Erico does. Everything else is either a copy or a knockoff or something else. It is used being an exothermic weld. It provides a secure connection for your grounds. It consists of, the welding material consists of copper oxide and aluminum, and with a energy source lighting it and a process, it does a chemical reaction and creates a copper weld for use in your grounding networks. The benefits of the Cadweld is it is lighter than a mechanical. It also provides, if done correctly, 100% coverage of the connection, where some mechanical connections will not provide that. A mechanical connection can loosen over time, chance of corrosion, many different things that can happen which will degrade your grounds and at the least cause issues with electronics. At the worst, you could end up having a safety issue if something is no longer grounded properly, where someone can get hurt. So, as this is one of the best, or the best way to connect your grounds, we're going to run through the application of creating one using the Cadweld Plus system from Erico, and then what to look for when troubleshooting your connections. So first off, as you can see here for the agenda today, we're going to talk about safety first, very important. Then we're going to go to preparing for the weld, the actual installation, and we got a little video showing this, the inspection, and then troubleshooting. So first off, like I said, safety is of paramount importance when using a Cadweld. You are dealing with a chemical reaction that uses heat and fire. As a result, you're looking at 2,500 degrees when this is done. So very hot molten metal. As you can see on the picture, leather gloves are imperative. The heat, even with the gloves, the heat coming off the mold can actually get through the gloves, but the gloves add a little bit layer of protection for you. Eye protection is a must. And one thing that is not here, which is also a must, is closed-toed shoes. No using flip-flops to create these. You might be in for a world of hurt if you do, if it happens to splatter. So safety, very important. First thing, prepare yourself. Don't go into this just thinking, hey, I can do whatever I want to do, or you could get hurt. Preparing the mold is also part of the safety too. There's some safety factors in preparation. But what we see here on this slide is, some of you may be familiar with the traditional Cadweld, and then there's the new Cadweld Plus. The difference being you have an open tube, which you actually physically have to pour the welding material and starter material into the mold, where with the Cadweld Plus, and you have to use one of these discs, and it has to be set properly, or else you could run into a mold that is not properly created. The Cadweld Plus is in these little cups, almost look like a little Keurig cup, and that everything is self-contained and it is electronically ignited. The traditional Cadweld, you have to use a flint starter, therefore you are right up next to the mold. Where with the Cadweld Plus system, standard cable off the impulse is 6 feet. You can, if you want a little bit more safety, can get a 15-foot cable to be away. It's also, there's not as many regulations to travel with or ship the Cadweld Plus versus the traditional, because the traditional, if you pop this lid, all that welding material that can light on fire is now exposed. Some of the things that are in this picture that you also use in the Cadweld Plus are these two brushes, the clamp, the mold, the blowtorch. And we'll show how that works here later in the slides. Here's an example of your molds, and you want to verify before you start each day that your molds are in good condition. A mold is engineered to last for 50 uses or 50 welds, but that's based on if you take care of it. And we'll go through again the proper methods of taking care of a mold prior to using it and continue to use it. But here's some examples of different things that can happen to a mold that can affect the quality of your welds. So you can have a chip in the parting face. You can start to where the chamber where the disc sits starts to wear, therefore it doesn't sit properly if you're using the original. The mold starts to part its face, it starts to wear out. You have a chip here down in the weld chamber, and then of course an opening. All of these can lead to a poor weld. You can see here what you want to have: a well-defined smooth face, the tap hole is straight and well-defined, and your weld cavity is well-defined. For every mold that you use, to verify that you're using the right mold, they all come with a gold plate on the side. It specifies the part number. It specifies what your conductors are. In this case, it's a 4/0 concentric to a 4/0 concentric. It uses, and this shows which welding material you use using traditional or the plus system. Here it says that you use a 150 weld material or you do the 150 plus. You cannot mix and match molds and weld material from different vendors. You need to be, if you're using Aeraco, it needs to be Aeraco. You also, when we get to the troubleshooting, you need to make sure that you use the proper weld material and the proper conductors. Not using any of these specifically could lead to a poor weld. So to start off, you want to attach your clamp. A clamp is very important. You need it because, again, this will become very, very hot even after just the first use. Again, we're talking 2,500 degrees, enough to, you could actually see it red hot if you pop the lid. You put it in, attach the clamp, and get ready. You then want to make sure that you thoroughly clean your weld. It needs to be clean. Dirty weld can attribute to damage or poor construction of the weld. You also, this is one of the safety features, is you need to blowtorch the weld. These are graphite. Graphite sucks in moisture. If you have moisture in here, when it heats up, it can super expand. And you could have something where you have a blowout of one of these holes. At the least, you could end up with a poor quality weld. On the safety side, it could cause a safety issue. So it is imperative that you heat up the mold with a blowtorch. And if there's a lot of moisture in there, you can actually physically see it evaporate out of the mold. Once you have done this and you do an initial weld, it's already hot enough that the moisture is not a problem, and you can keep using it throughout the day unless you let it sit for a while and it's really humid, things like that. Then you might want to blowtorch it again. But if you're continuously doing it throughout the day, blowtorch it in the beginning of the day before your first weld, and you're good as you continuously use it. And don't have to do that every time that you do a weld, just when you initially start for the day. You want to take, now, one thing, when cleaning the mold, you want to use a soft kind of horsehair type brush. Do not use a wire brush. It will scratch up the graphite and will deform the weld cavity. So it's imperative that you use something, a softer brush. Erico has those. It's like a medium hair brush, and it's stiff enough that it can get the excess slag and different things like that out, but it doesn't ruin your mold. Next is you want to heat up and you want to brush your conductors. Again, heat up, just get some extra grime, dirt, anything, give it a good scrub. Now here you can use a wire brush on your conductor. Give it a good scrub, make sure that you get any of the oils or grease that are on the conductors off, and give it a good clean and a heat up and dry them out. A next important part for a quality weld is make sure your positioning of your conductors is correct. If you have some excessive bends, it may not allow the mold to close properly. If it doesn't, you may have some blowouts of the weld material. These clamps are made that you know it's fully sealed because the clamp does a little pop at the end where it has like a groove where it seats. If you don't feel that, and you can actually feel it where it almost got like a little hiccup or a bump as you close it, then it's not closed all the way and it's not tight, and you could have issues. So it's imperative that your conductors are set properly and you close the clamp all the way. So what we're going to show here is a little bit about traditional and Cadweld Plus on the installation of it. So if you're doing traditional, you have to use one of these discs. These discs basically allow a little bit of cook time. It's not long, but it holds up the weld material after it's been ignited just enough that the slag has the time that you don't want. The slag has time to float to the top and the copper has time to float to the bottom. So you want to make sure that your little plug here is set correctly. Now with the Cadweld Plus, there is no disc. You just set the proper Cadweld Plus unit into the mold. So again, like the pictures before, this is traditional. You have an open powder. Of course, for safety reasons, this person's wearing his gloves, which is very important. You pour in the weld material, and then at the bottom, there is some finer material, which is the starter material. You put half in the mold, you put the other half around the ring, and if you close the lid, there's a little cavity, then you put it in there also to start it. With Cadweld Plus, again, you just set your cup straight into the mold. You can see here the starter material at the bottom. Here's where they're putting half of it inside, the rest of it around this ring and up in the launch cavity. With the Cadweld Plus, you just simply hook it up to the impulse igniter. So here's the igniters for the various types of Cadwelds. You have, like I said, the traditional flint lighter. You got to get in close, or you have if you're using the Plus, this is their new impulse. This impulse provides a little bit more safety than their older unit. This trigger right here is covered, so you do not need to, you won't accidentally hit the button. You have to lift the trigger cover, then push the button. Again, you have 6 or 15 feet of length that you can choose from. There's indicator lights on the top that show you the progress, because it is about 3 to 5 seconds of an ignition but you can see the actual ignition happening up on the top. And then it doesn't show it here, but you can actually get an adapter. This one right here is using, I believe, AA batteries. it does have an adapter that you can get, which you can use either a Milwaukee or a DeWalt rechargeable battery. So you can just simply recharge your battery each night, and you have not having to purchase or install AA batteries. So from that point, you'd go to the ignition and light it up. Again, with the traditional, you got to get in close with the flint lighter. With the Cadwell Plus, you can step back some. Now, you still need to use gloves with the Cadwell Plus. I've heard stories of sometimes a molten ball of metal coming out of the mold. On our own table, we have remnants that we use for demos. We have remnants of weld material that's on that table, just because sometimes it does spit a little bit, especially if things are not set up correctly. So then you don't have anything to remove per se on the traditional Cadweld. You just have to open the mold, but the Cadwell Plus, you do have to remove the cup before you move forward. You open it up, you can see your weld. You can see here the good copper gold color. You don't see a lot of slag. There's not a lot of running around. So this would be a runoff. So this would be a good weld. And we're going to have some more examples of what's a good weld and what's ones that you need to reject and redo. Now, as soon as you're done with your weld, and before you move on to the second weld, it is mandatory that you clean. This is where I talked about maintaining your mold. You need to clean it every time you use it, or else you're going to get a buildup of slag and your molds will no longer be effective or ones that you can use. So I have a little video here that I'm going to play that shows the installation of a Cadwell Plus. It's only about 3 minutes long. So I will let you start this and we can watch it. It takes a moment to get started up here. I'm sorry the sound isn't coming through, but you'll be able to see the pictures. It's just music. So wanted to talk here about this this page here that creates a permanent bond that will not loosen or deteriorate. These are engineered to last longer than your conductors will. I was at the plant taking a tour and doing some training with Erico, and they hooked up two concentric conductors, and they had a Cadweld in the middle, and they have a machine that will put 10,000 volts through a connection. And you could see them as soon as they turned it on, the metal of the conductors fatigue. And throughout the process, the weld stayed, and ultimately the conductor blew up. And molten metal started leaking out of the center of the conductor, but yet the Cadweld was perfectly preserved and maintained that connection. So it's engineered more than your conductors that you will use. So again, because it has 100% coverage, it maintains a lower resistance, has current carrying capability equal or greater than that of the conductor you're using, will last longer generally than your conductor, can easily be inspected, and it's easy to make, as you saw there. We can train you. We can even provide you a card that says you've been trained. And it's not something that needs maintenance. Where a mechanical, you may have to check it to make sure it's not loosened, no corrosion, nothing like that. So let me get back to our presentation here. Okay. So now you want it, once you've done it, you want to inspect. And here's some things that you need to look out for when doing a inspection. First off, if at any point you see conductor coming out of where the weld should be, so if the weld did not create properly, and you can actually see conductor like this, where the top of the weld, it was too thin or wasn't even formed, that is an unacceptable weld. You can also see here the minimum acceptable, the normal amount of weld for this type of weld. Minimum acceptable is that everything is covered. Normal is actually a little bit over that. Higher than normal probably means that you may have used the wrong weld material, or it's just slag that can be simply knocked off. So a couple things to look out for here. Again, no portion of the conductor within the confines of the weld should be exposed. Maximum depression under the riser on horizontal connections after the slag has been removed. You cannot assume slag is part of the weld. That stuff is so brittle you could knock it right off. Should be no lower than the top of the conductor. And here's some indications of a low fill, and then indications of why you may have had a high fill. Low fill, you may not use the correct material. Your weld may have deteriorated to the point that you're leaking material when it goes to form, or something happened to your conductor. And then excessive, you can see here, you have too many contaminants, or the weld material was the wrong size for the connection you were doing. So here's some examples of acceptable welds. This is a very good one, nice gold patina. This one is acceptable even though it looks kind of ugly. This right here, what you can see in the different color change, this is all slag. So that slag can be knocked off, and it would probably be about something like this. There's a little bit of depression, but as you can see, it still completely covers the conductors. So this could be considered an acceptable, and it's not pitted where there's a lot of slag in there. It still looks pretty much like copper, so it can be an acceptable one. Now what we're going to do is kind of go through troubleshooting of unacceptable and why it's happening. So here is the weld. You got a whole lot of things going. You have pitting going on here. You can see a lot of slag inside of that weld. and you have a lot of leakage. There's a lot of things that are going on here. You have, you need to use, if you're not using the right clamp or did not close it properly, did you clean it properly? Did you make it so that it wasn't moist? Did you get all the grime? And it won't necessarily feel moist, but there is water in there that you need to get out. And you have to be careful when removing the mold as not to chip, or removing the conductor, sorry, to not chip your mold. So here's where the mold may have been chipped, the wrong conductor was used, a lot of leakage came out, and your weld almost became half slag here, and it even fell in the middle. Here's one that you might have a weld, but you have fins. That's an indication that that's leaking out in between the two halves, or the separation of the mold, the opening of the mold. So again, check for the mold not completely closed, or it just could be worn beyond its life and needs to be replaced. If you're definitely closed and you're getting something like this, it might be time to replace the mold. Now, there is things called mold putty, where if there's small chips or things like that, you can get to reform, say, the weld cavity of the mold or something like that inside to get a little bit longer out of it. But, and that's where you have to decide, am I getting quality or not? You can use the mold until you don't have quality. Once there, you might want to replace it if there's nothing you can do to fix it. Here's a situation where, if you can see in the middle, it's pitted and a lot of like it's sunk in the middle. This is an indication that your conductor separated, and all that weld material, instead of going around your conductors, it went around here and here, but it settled into a big block in the middle. This is something you have to look for. If you do experience this, it is recommended that you reject it and start over. Color is an important part. As it says here, it should normally be a gold or bronze in color. It's copper, so it should look like copper. In a really good connector like we saw before, you have that nice gold color. But and silver is allowed because it's just tin sweat on the surface and is a normal condition. But if you have a situation where you're getting, because the slag color has kind of almost like a bronze color to it, a reddish hue. If you are seeing that a lot within your weld, there may have been a situation where the weld material, if you remember that disc, if you're doing traditional, has to be placed properly, or that area needs to be clean and not chipped. If it's deformed, it creates a cavity. And if that material doesn't have the time, even though it's very quick, it doesn't have the time to separate, you can get slag that falls in with your mold, and now you've deteriorated the quality of your mold and made it a possible safety hazard that if there's a lot of slag, it may be too brittle and it could actually break. So here's some examples where you see a lot of that gold color. The color doesn't really look right. Here, again, there's a lot of slag that's fallen in there. It's kind of deformed in the middle. The color looks horrible. You might want to rethink rejecting it. Now, you're not going to always get one that is pristine gold color like up above, but it should have a good resemblance to that. You might get a little bit here and there, a little pot mark here and there, but if it doesn't look good, it probably isn't good. Here's one where it's called surface finish. Surface of a Cadwell connection should be reasonably smooth and free of major slag deposits. Again, you can see here that the slag comes all the way down about halfway through the mold. That's not going to cut it. That could be knocked off real easy, and then you would have an insufficient connection. right there, if slag deposits cover more than 20% of the connection surface, then you probably need to look at replacing it. And again, if it works well, you have the nice gold color and the slag just sits at the top, and it's simple to just knock that off with the tool. Just comes right off. It's very brittle. Here's one called for porosity. What this is pinholes that happen within your weld. You might have some, but you can see the examples here. Here, this is completely covered, as smooth as the picture, but you don't see a bunch of pinholes. Here, it's all over the place. That means there was contaminants within the mold, and you can have pinholes, but like it says here, basically take a paper clip and put it into the pinhole. If the depth of the pinhole extends beyond the center of the conductor, you need to replace it. That means you do not have a quality weld there. You have gaps. So you need to verify that those pinholes aren't too big. And just as simple, like I said, just like a paper clip and a paper clip, put it in. If it barely goes in, that pinhole's fine. But if it's something like that or goes too deep, you might think about replacing it. So Cadwelds can be connected to, say, pipes, if you're in the wireless industry, straight to poles, different things like that. But like with everything else, you need to make sure that it's a conductor in a sense. So you need to make sure your conductor is prepared. You need to make sure that all paints, oils, grime are been scrubbed away and clean. Grease must be removed, and to get that off and clean it off. They recommend a grinder is the best. They recommend a grinder, but if you don't, you could have this where it does not get a proper seat to the flat surface and therefore comes off. So here's a few things. So when welding to ductile iron or cast iron, weld does not stick to surface. Again, make sure the coatings are removed, hit it with a rasp, a grinder, make sure the metal is bright, and clean the surface. And there is a product that you can use called Cadweld XF19 alloy welding material, which is a little bit different, but will allow you to also be able to do that. The mold does not close tightly, so you need to see if your clamp needs to be adjusted. Again, like I said before, make sure your conductors are not bent too much. If they're too solid and there's too much of a round, you may not be able to get your clamp closed, and therefore you're going to have some of that spill out, and you may not get a good weld. Also look for anything blocking it from closing, like dirt or a piece of slag that didn't get clean, something like that. And make sure you're using the proper tools, the proper mold, the proper conductors. That definitely will keep you from creating a proper weld. Conductors do not weld. So you'll need to look at if they don't weld properly. You need to make sure that you did go through your cleaning process and properly clean them and dried them. Again, using that wire brush and a torch will help you there in getting those prepared. Also make sure that they're positioned correctly. If they're out of position, you could, again, create that hole in the middle where all of your weld will sit in the middle and barely attach to your conductors and does not provide for a good weld. Welding material leaks around conductor. Well, first off, you need to make sure you can use what they say packing material around the conductor after the mold is closed to keep it in. You also need to make sure you're using the proper mold, the proper conductors. They also recommend you can use wear plates And of course, if it's just past its life, you need to look at, if it's a consistent thing and there's no other reason, it's probably time to replace the mold. It's worn down too much that it's escaping, and if you're seeing a lot of escaping, you need to run through your cleaning process and also check your mold. Insufficient fill material to cover conductors. Again, using the proper material. As you can see here, a lot of these troubleshooting is just about using the right items for what you're trying to do. The right mold, the right conductors, the right weld material. And again, that's where that gold tag on the mold comes in handy, because it tells you everything that mold does. So if you're not using exactly what that mold says, you are going to have problems. So again, positioning and of course the mold leakage and then conductor movement. We talked about this earlier, riser too high, mainly using the proper welding material, or there could be moisture too, but also a good cleaning, I would add to this. Connection covered with excess slag. Again, that chipped tap hole. The disc moved when the welding material was dumped. Disc not properly not seated, or disc was not installed. Again, with the Cadwell Plus, you don't have to worry about placement of that disc. It's built to provide the necessary time for that to happen, where the slag and the copper separate. Similar to what we've already talked about, molten metal spits out of the crucible when making a connection. Here's where it becomes a safety issue by not taking the moisture, where it could actually cause it to spit out of the moisture in the mold could actually cause it to spit the metal out of the crucible. Heat it up, dry it off, get any contaminants out of the way. Mold packing material, and so forth. And of course, just making sure your mold's in good condition. So we're getting here near to the end. Some other items that we can help. So of course, we are the rep for nVent AERCO in the broadband and telecommunications. As I said before, we can provide you with training on using a Cadweld. We can provide a little card signed that says you went through the training. We can provide a little sticker that goes on your hard hat if it's required at the job site that you're at. There's some other examples of material that we can provide, and to assist you in picking out. There's molds for many different connections, depending on what type of connection you're making. So if you have questions, just reach out to us. We can let you know. We can get you quotes through your distributors that you use and anything like that. I've come to the end. Is there any questions that anybody has at this point? I will take that as a no. What you see here is our contact information with which outside person covers which territory, along with who their inside person is. I'm an inside person here at S&S Solutions, inside sales. So if there's any questions, you need any training, you need to check out what's available for you, we'd be happy to sit down and work with you and get everything lined out. With that being said, we are done. We will send out this recording, and along with, I'll go ahead and send the slide deck so you can have those remedies for different troubleshooting. And so with that, we will be done. Thank you and have a wonderful day.